everything from the battery to the induction drive inverter to the coils to the temperature sensor, like all of those pieces would be basically impossible for us to have done in-house at a cost profile that would let us ship the product at the price we're targeting. And so you would have to basically just go with off-the-shelf stuff because that's where the supply, like the economies of scale are. But we managed to be able to slice it at a lower level because our manufacturer has access to that lower level supply chain at scale. This is enabled basically from a product standpoint is, and I said this earlier, it's like, I'm pretty sure it's the most powerful and most precise stove ever made.
Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm here with Sam D'Amico, the founder and CEO of Impulse. Sam and his team have designed and manufactured an electric induction stove or cooktop. I've actually gotten to take one for a spin, and I have to say it's an absolutely gorgeous product. It's super intuitive and fun to use with crazy performance. It can boil a liter of water in 40 seconds. Sam and his team invited me to check it out at their office, and the day I came, there was actually a Michelin star chef doing some user testing, which was really fun to see. He was geeking out about all the new things he could do in the kitchen thanks to the capabilities of the stove. In the context of climate change, this is an important product for at least a couple of reasons. One is that we need to fully electrify our homes, of course, in order to transition from fossil fuels, and gas stoves are one of the hardest things for people to give up. Another is that the stove that Sam is developing has a 3 kilowatt hour battery integrated into it. This means that every stove installed represents more energy storage on the grid, which allows us to better utilize the intermittent supply from renewables like wind and solar. I'm really excited to get into all that with Sam. To introduce him quickly, he has some serious consumer hardware chops. He started his career as a hardware engineer at Google X back in the Google Glass days. Since then, he's worked on hardware for Oculus, Facebook, and Google before founding Impulse in 2021. Sam, I haven't told you this, but I think you're a very cool guy, and I love what you're doing. And you've actually been on my dream podcast guest list for almost 2 years since I first read about what you were doing. So really happy to have you here. Thanks for joining.
Yeah, really appreciate it. Really appreciate you having me on.
And I think it must have been a couple of years ago, you guys were making an announcement about your Series A close, I think. Was that when you first announced?
Yeah, that's probably when we
what you were working on.
Yeah, we decloaked a bit. Yeah, actually, we decloaked. That was when we kind of decloaked that what we're up to in the general scheme, without having to go into too many specific product details or anything like that.
Right. And I think this is when I first read this, that you actually started out this sort of Impulse journey on a mission to figure out a way to cook pizza quickly at home with electricity, I think. And I was just curious if we could start there. Why pizza? What were you going after there?
Yeah, it's funny. It's my last name might give this away, but yeah, I'm Italian. But it was actually funny is I was in this like Japanese pizza place like in Tokyo. I think it's called like Savoy Pizza or whatever. And my pizza comes out in like 45 seconds. They're cooking it kind of like Neapolitan style, and they've got this super hot brick oven and all this other fun stuff. And so I'm just like, how could you replicate this in a tabletop device? And sort of the idea chain started making me realize like, there's no way that 1500 watts from a 120 volt plug would get you that. Like you couldn't do it. And it was interesting because at the time there were a number of very compelling smart oven companies that existed. And I kind of looked at all of them and I was like, there's something missing here where it's like, the key innovation of the 2010s was everyone got a smartphone and you could put the guts of the smartphone in any device. And I think that's like, honestly, a big chunk of my experience at Oculus as well was kind of like, oh, suddenly this desktop only VR thing could now absorb the guts of a phone. And now suddenly this becomes a new type of mobile computer, basically. This obviously hit everything from VR goggles to juicers and stuff like that. And so effectively that technology revolution was at its peak at that time. Like it was kind of like everyone had access to this new technology. The manufacturers were aware of it. And like this was starting to happen. But what was missing was there wasn't yet a like killer app in terms of performance or new capabilities that would get people across the line. Like this is before you could definitely make it perfect. Like you can make cooking perfect. But imagine if you were a Michelin star chef, would you use one of these products? And it's like, yes, in some cases, but it's not a universal yes, right? And so what I realized was like, well, I want to make the lowest, like the most novice user or a pro walk up to this thing. And the user experience is the same as like their existing appliances, but it's just better by key performance axes. And so that was kind of the key, like the realization of like what I kind of wanted to do from a product standpoint. And then realized that there was this block, which is you couldn't make a stove or you couldn't make an oven or stove or whatever better. You were limited by the power that was available at the home electrical connection. And very quickly, this is like 2019, I went and like bought some components. I bought some Zoom pizza ovens from their bankruptcy sale. Like I went and kind of did some research on this pre-pandemic and realized that the best move was to integrate batteries in the appliance. And if you could, because the reason is 120 volt plug gets you 1500 watts, augment that with high discharge rate, presumably lithium iron phosphate because of safety features, batteries. And you could build an appliance that had north of 10,000 watts available in a multitude of form factors, not necessarily just ones that are installed, not necessarily tabletop ones, et cetera. And so that was kind of like the entry point and was like, yes, you can make this sweet pizza oven with like infrared lights and all this other stuff. That was step one. Step two was kind of like, and I started working on this in like Q4 2019. I was like, what products would make sense here? And what was the big picture? And how big would the batteries be when practically deployed? And so the next step was kind of like, okay, you want to actually do installed appliances, which is counterintuitive because those are wired up to the building mains on 240 volts. Like they're not like, and typically wired up on 240 volts. And what you could then do is, and then you're like, how big is the battery? And then it was kind of, okay, the appliance that now is installed in the house stealthily installs a reasonably large battery in the house. And then you think of how many appliances there are and what that sums up to in terms of total energy storage. And it looks pretty dang similar to a Tesla Powerwall. It's just you built it from multiple pieces versus having a singular one in one position in your house. And then the kicker is all of your appliances are more awesome from a key, like from like a performance standpoint, all the appliances are more awesome.
Yeah. Was that realization when you started thinking about climate change or this in the context of climate change? Was it always sort of an electrification play? Or was it really like, how do I make better pizza play initially?
So I think the feat, and I think it's actually important to kind of anchor on, you need to make an appliance that like people will want to buy. And because the average consumer, I mean, people on this podcast are probably not the average consumer, but the average consumer wants to buy the best thing available at the price point they're targeting, right? And this is what Tesla found successfully and seems to be holding up. The like difficulties of home electrification are something you find out after you decide to make the decision to switch to an induction stove or something like that. You then be like, okay, I can't do this very easily. But the point was basically, let's lead from the performance angle, Trojan horse the battery into the home, and then that's kind of the next sort of steps fall out from there. And yes, I fully understood that like the goal here, once you put those batteries in the grid, is utilities are willing to pay for that capacity through virtual power plant programs, through a number of different schemes. And if you look at kind of where peak demand is for stuff like cooking, 6 p.m., and what the cleanliness in terms of CO2 of the California grid is, you can quickly see a mismatch between when there's abundant solar and wind and when people want to cook. There's a number of things that line up where, yes, this ends up being remarkably impactful for climate change because you can now move huge chunks of the residential energy consumption onto clean energy. You essentially can move, like when the natural gas peaker plants are needed, like, well, you just put the peaker plant in the house is the end game. Then the other thing we thought about, and I think this is actually kind of goes back to the first point about the product standpoint, is apparently more than half the people that want to fully electrify their home are held up because of their gas stoves and their gas stoves specifically. This is where you have to just win on the stove has to be better, because that is the thing for why they keep maintaining their natural gas relationship. And if you maintain that relationship, you maintain the fixed costs on the bill, no matter how much gas you use. And then you're incentivized to also use it for heating. If you're in places like San Francisco, you don't have AC probably, maybe not yet. And so getting people to switch to heat pumps and other things is harder because of the stove for this counterintuitive reason, basically. And so it's a Trojan horse, not just for getting the batteries into the house, but for electrifying the house fully, because you sort of got rid of the key reason they wouldn't do it, because they like their gas stoves. And there's two approaches. There's like, I can tell you that your gas stove is killing you, or I can say, which generally will negative polarize people to be like, get your hands off my gas stove. Or I can be like, we just crush this thing on all metrics and you will willingly come to join my team.
Right. A big juicy carrot rather than the stick of...
Yeah, it's the big juicy carrot versus this, and not overcooked, versus the stick.
Perfectly cooked juicy carrot. Yeah. Yeah, I mean, I'll say, like, I have those same tendencies. Like, I love a gas stove. That's what I grew up with. I always grew up thinking that was sort of the pinnacle of cooking. Like, that's what I would want in my kitchen. And then your point being that kind of motivates people to maintain their hookup to gas. And then once you have gas, especially in California, the delta between gas and electricity pricing is so high that, like, it makes sense. So I might as well get a gas dryer and a gas furnace and all of that. Yeah, that makes sense. So tell me about the product. Like, let's get into that a little bit more. Like, what have you done to make it more appealing than a gas stove to people?
So this is actually a funny story. Is like, I went and DM'd someone about being about to quit my job in April 2022 and what we were thinking about putting in the product, basically. And I can potentially read out this thing because I think it's actually really funny, and it actually it's kind of a calling your shot thing. Effectively it was, I figured out the missing piece to get appliances unstuck from the sort of route they seem to be in, and it's orthogonal to most of the other attempts around adding tons of intelligence. Been refining the concept at this point for over a year, and I'm weeks from kicking this off formally. But the end goal is something like an induction stove with non-fail user experience, pots and pans that have closed loop temperature control, and enough power to boil water really fast, or power a restaurant grade wok. And so that was the like April 2021 shot call, and I think very confidently we have landed all of those things. And so that was the initial product scoping where we were like, okay, let's make sure that we build the most powerful and most precise stove ever made. And then people will then willingly bend over backwards to put that in their house, which is often a painful and annoying exercise. And then once we've sold a bunch of these, we've now stealthily deployed megawatt hours up to gigawatt hours, because if you replace every high-end stove, you're in the gigawatt hour zone. Of battery storage onto the grid. That was kind of the setup, right? And then it's kind of like, okay, what did the execution actually look like?
Just on that point, because I want to understand this, what does it actually look like for us to take advantage of all this distributed storage on the grid? So we have lots of, 3 kilowatt hours, and just to put that in perspective, that's what a power wall is. What,
a quarter of a power wall, about a quarter of a power wall. Yeah.
Okay. So the idea is you have a lot more people are going to have stoves than power walls. You have a lot of kind of smaller batteries distributed out behind the meter on the grid. Does it, to fully take advantage of that, does it require coordination between that storage and utilities? Is it just about every home having kind of smart home or like automation software to figure out when to charge and when to discharge? What does it actually look like to take advantage of that?
Yeah, and there were layers to this, and like I want to be very clear what those layers are, because there's kind of like, this starts from, okay, now your stove, at the 0th layer, it's basically your stove doesn't draw peak power ever, because essentially you've got a battery that can supply well north of 10 kilowatts to the appliance internally. And the charger, you couldn't necessarily run the device just off the charger at full power, right? Like you're going to be in this situation where you have a charger that is sized mostly because it needs to fit in the product, and then the battery is sized for peak power delivery of for the use case. And then whatever capacity you actually get for the battery is like a bonus. Now, there's a couple reasons to make it 3, one of which is that's more than one meal. It's like 3 meals. But then the other reason is that you start getting the tax credits because it's a battery storage product. And so that kind of scopes you but really the user experience piece is based on power delivery, not necessarily energy. You don't need a lot of energy in addition, because especially when you're cooking, you're not using, we can put 10,000 watts into one burner. We don't need to do that for more than a couple minutes in an extreme case where you've got this giant lobster pot or something like that. And so
you have capacity to do it for 20 minutes.
Yeah, you got capacity to do it for a while. And so going back to, so that's layer 1. It's basically your stove doesn't use peak power. It uses you can plug it into a 120 volt plug. It will draw no more than 1500 watts. You can plug it, you can wire it 240. It won't draw that much more than that. So you can do that. And then the second piece would be, and that already saves a ton of pain on the grid. It basically means that PG&E doesn't have to upgrade people's service anymore. And maybe you don't have to do a panel upgrade for your house or something like that. That's layer 0. Layer 1 is then, yes, this has a battery. It's on the internet. It can choose when to charge and discharge based on what makes sense. And so then you can now start moving that, let's call it 1500 watts or whatever, of recharge time around to best optimize for let's only charge when there's otherwise curtailed solar or something like that. So that's layer 2. Layer 3 is okay, so we have an inverter in the product, not just a charger. We can push power back into the house and basically lower the consumption from the grid of other appliances, as they're just happening naturally. Then from a consumer perspective, you save money. And I think we modeled this around 20% if you're in some of these kind of high tariff zones in California. It's you potentially can save about 20% of your home energy bill just from only your house kind of now shifts more of its consumption to off-peak energy effectively. So that's kind of those are the 3 layers that can happen behind the meter, can happen without any third party, can all this other stuff. So then the next one is, the goal here is to build a giant power plant and sell the capacity like it's a giant power plant. You can actually go and do that. It's not it's not an unheard of thing. And there are a number of companies, I think some of which you probably may have talked to, but Renew Home is a good example where okay, your Nest thermostat, it sells negative watts. It sells not heating or cooling your house to the grid. But imagine if you did that with battery capacity, that works. Tesla's got this program called Tesla VPP. There's a number of programs where essentially they will bundle, maybe it's not just their assets, but it's a number of other assets, and offer that to utilities in regions where they've got enough capacity as hey, here's a product. Here's a product and it looks kind of like a power plant. That's the layer 4. And then there's layer 5, which looks like Tesla Electric or Base Power Company. And Base is probably a better example of this, where it's you straight up take over the utility billing relationship and you're a retail electric provider. You switch your bill pay from PG&E to this new company that essentially is a virtual utility. They don't actually own any of they're not like PG&E where they own all the infrastructure. They're they're essentially just or they're not essentially, but they look more like a virtual private network or something like that, but for energy. And then they can then trade the capacity of your batteries as part of a combined billing system because they control the meter, they control the battery, they know they can do all the accounting properly. So there's kind of that. That's the whole spectrum here. We've realized that because our battery is 3 kilowatt hours and not 15 to 25 or something like that, the capacity that you can just internally consume in your house, it matches reasonably well to 3 kilowatt hours. So you can end up playing with the virtual power plant abstraction layer versus the we would need to preferentially launch in Texas and do and become a energy company where you would sign up for Impulse basically. And then maybe we then try to sell you a stove or something like that afterwards. So that's kind of, hopefully that explains the spectrum of how this looks from a from that perspective.
Yeah. What kind of adoption do you feel like you need to have to get to that sort of critical mass?
I've talked to folks in this zone. It's like the benefit here is there are a number of middle tier aggregator providers that like will bundle a bunch of distributed assets. I don't think they have a minimum participation per se. If you want to cut them out, you need to have a certain amount of capacity. I think it's in the, I don't know that off the top of my head, but imagine mid tens of megawatts is kind of in a specific region or something like that would be the starting point based on understanding that I have.
Right. Okay. But it's something with the kind of middleman. It's something you can
you can scale up. This. Yeah.
Yeah.
Yep.
Okay. Cool. Yeah, I think that illustrates it really well. Okay, so back to the power or to the product itself, because I think it's helpful for people to just understand like what makes this an actual upgrade in terms of your user experience and product relative to high-end gas stoves today. And I mentioned you can boil water in 40 seconds, which is pretty awesome. I personally hate how long it takes to boil water on my gas stove. What else really sets
probably
it apart?
7 minutes for a liter. The shape and size of the bottom of the pan, but it's usually between 6 and 7 minutes on a gas stove, on a typical gas stove.
When I visited your office, was talking about just how much heat is lost to the air, to sort of the surrounding
60% approximately.
60% of the energy in a gas stove is just going to heating up your house. So you can heat water so much faster, cook so much faster. What else sets it apart?
Yeah, so what we realized that there was a couple different things here where if you think of like how an oven works, you set a temperature. You say like 350, I bake at 350. But on a stove, you put the pan on the stove when you set a number that's like 7. And imagine, and that could be correct for frying an egg, but imagine that egg starts drying out and at the bottom, and now there's like less water there and all this other stuff. You would actually need to dial it back to like 2 or 3, or to otherwise not burn the bottom of the egg, basically. And if your oven did that, you would just light your cake on fire, right? Like it would be this sort of situation where like you're baking a cake, and 20 minutes into the bake, when it kind of starts drying out and getting fluffy, like then it starts to turn to carbon because your oven was set to 7, and you have no idea what that means in terms of temperature.
Right. So you have, and I saw this, you have kind of temperature sensors built into the cooktop itself.
Yes. And this was very difficult. So this was very difficult. And I actually think there's like a couple layers to talking through like how and why we did this. So it's kind of, first we were like, we need to make the stove more powerful than every other stove. So let's pick a really ambitious target. Like let's put 10,000 watts into a burner, because we looked around, we're like, some of like the bigger burners on certain induction stoves are like 5 kilowatts or something like that. We're like, okay, let's just make sure we're double that. And so we're 10,000 watts. We then built that, and we very quickly realized like, you're going to burn stuff for the same reason I just described. Like it'll get to temperature and then you won't know how to turn it back pretty quickly. From the very beginning, we were like, okay, we're probably going to also want this temperature control thing. We didn't understand how critical it was, because we're like, this is a good feature because Breville and a couple other big companies have realized it's a great, like the best reviewed induction hot plates have temperature control. And so we were like, okay, we want to have that feature too, because we can then sous vide stuff. You could now replace a bunch of common kitchen gadgets like sous vide or air fryer or Instant Pot would be kind of the thinking. And then suddenly your stove takes over more of your kitchen. But then we started cooking with 10,000 watts, and we were like, okay, we need to actually figure out a way to throttle the power really quick. If you put a dry pan on there, it needs to be safe. You got to pass all the UL standards and all this other stuff. And so we very quickly realized we had an R&D challenge on our hands and had to invent a new type of temperature sensor that has never been used before in the space. And the other piece is the way induction stoves usually work, and the way that if you go and buy an induction stove in the United States today, something like 60+% of them have one company's electronics inside. If we went and bolted on we couldn't raise the power output of their standard stuff. Maybe you could hack it, but like it would be kind of tricky. But then you definitely couldn't bolt on this new sensor and then get them to open their firmware up to you and do all this other stuff. Like it was just not going to be a thing that would be expedient or ship quickly or anything like that. It would turn into this long adventure. And then the other piece is the way the safety standards work with like UL and all these other folks is if you want to do something cool, like we have the awesome knobs and all this other stuff, you have to control that whole end-to-end system as part of it. So it's not just that you sign up for someone else's induction drive, you sign up for the whole thing effectively. And what this means is like, essentially we had to approach this kind of not unlike Tesla, where we're like, we will need to do the full stack from the battery all the way up to the knobs of the system so that we could actually deliver something that was differentiated on any axis versus the existing folks in the industry. And so that was the thinking on like why we went this aggressive with this product, because in some sense we had to build a product that was differentiated enough so that we could compete as a new brand in this space.
One of the things that really stands out to me as impressive is just how quickly you've done that. So you've kind of built, like you said, the full hardware stack of this product from scratch, essentially, in what, 3 years? 3 years,
yep.
And you know, while
seed round closed under 3 years ago.
I mean, that's really impressive. I'd love to hear from you kind of what your strategy for moving that quickly has been, thinking about how you've built your team, how much you've done in-house versus partnering, that kind of stuff, or really whatever you would call out as kind of what's been the trick to moving so fast.
The big story, and this is the big lesson I learned from working in consumer hardware in the Bay Area. So like I typically collaborated really deeply with major manufacturers that they have good engineering teams internally, and especially in China and other parts of Asia. You can, if you write the spec right, there are engineers that can work with you hand in hand to co-design everything from components and modules all the way up to full systems. And the benefit here is like, there's a lot of talent in the Bay Area in the space, but there's just little enough that folks like it's hard for folks like me to hire, and folks hire you, right? For that reason, like there is, but the rest of the world, it's like, we should imagine that they assume the best, assume they're competent at this stuff, and they are. And so a lot of the thinking I had was like how best to leverage external manufacturing engineering so we could keep our team lean, but then also that every manufacturing related decision that we did as part of the engineering process would immediately map to a scalable production supply chain and like manufacturing way of working. So it's like when we go and update stuff from a design standpoint, like that ends up being something that will be able to ship 1 million units if someone ordered them from me. And making sure that happened was a big deal. Now, the other piece of this is like, you have to give away some of your Legos. Like, I think you're a hotshot engineer in the Bay Area. You think you are individually the greatest thing since sliced bread. Being able to essentially mentor, like your manufacturer will have like 100 engineers for your 25 or something like that sort of order of magnitude difference. Being able to kind of get them to do stuff for you means that you scale way better without having to hire everything from additional electrical and mechanical engineers down to tooling engineers, down to supply chain experts, down to all this other stuff. You kind of just need like a senior leader in each of these slots to be able to convey that information. And that's what we've largely structured our operation around once we got the manufacturing partners on board.
It's a great example for other hardware founders to kind of look to. And it seems like you've leveraged that really well. I took us down a little tangent there, but let's finish off on the product experience and what sets that apart.
Yeah, and I think this is actually there's some stories of that pull us back into the manufacturing weeds. So it's like, for instance, like you're building the full stack from scratch. This is going to be expensive and require a ton of work, right? So, but the fact that we basically pulled a top flight CM, actually 2, in to help co-design critical pieces of the system. So everything from the battery to the induction drive inverter, to the coils, to the temperature sensor, like all of those pieces would be basically impossible for us to have done in-house at a cost profile that would let us ship the product, at the price we're targeting. And so you would have to basically just go with off-the-shelf stuff because that's where the supply, like the economies of scale are. But we managed to be able to slice it at a lower level because our manufacturer has access to that lower level supply chain at scale. This is enabled basically from a product standpoint is, and I said this earlier, it's like, I'm pretty sure it's the most powerful and most precise stove ever made. And so you walk up to this thing, it's got, and let's imagine it's like off or whatever. It's got 4 magnetic removable knobs with tactile controls. We realized that like all of the touch controls and all this other stuff in the space were terrible. Also the same because again of the thing I mentioned earlier around like once you're kind of on a certain supply chain, like the supply chain dictates your controls if you want to pass UL. And so you walk up to this thing, there are removable magnetic knobs, you can clean underneath them. They have like turn and click. We really dialed this in so it feels fantastic. There is a large display which tells you what's going on, allows us to kind of expand the universe that is Impulse over time, but is also larger than I think any other stove display. That doesn't sound like a great achievement, but it does make it very clear what the stove is doing, which is often a problem for stoves that are a black rectangle. And so, because you don't necessarily know, like, is it hot or not, because the induction is invisible, right? And then we've got 4 burners, each of which can do 10,000 watts, which is about 3 times more than like a typical induction stove on high. And so from the experience standpoint, you walk up, you put a pot on, you turn the knob, it gets hot. It works just like you are familiar with. There's no sort of new tricks or anything like that. But then we layer on the temperature sensor. So in the middle of each burner, there's a temperature sensor. It looks kind of like, I'm trying to think the right way to describe it. It looks kind of like it's like a spring-loaded little cap that basically the pan pushes down. I'm describing things in my like electrical engineer way. You might be better at this.
Yeah, no, that's perfect. It's like a little raised
nub.
Yeah, spring-loaded. Yeah,
and it feels kind of like pressing a mechanical keyboard switch cap kind of thing. So you put a pan down on that, and now instead of that 0 through 10 that means nothing, or a low, medium, and then high that means something, but maybe it doesn't mean the same thing when your stuff starts burning, you can actually set and hold an exact temperature. That changes the entire user experience with the product, because now, and you can do things that no other stove can do. It's not just like, this is another induction stove. It's like, this is something new. We'll figure out the branding for it very soon, but like it is definitely something new. And I've done demos that are really simple where it's like, I just walk up to it and I fry an egg, but you can melt the butter to whatever browning level you want it to be, and it won't get any further because it'll just be at that one temperature. And then you crack the egg, let it cook. The bottom of the egg will brown. It will fry. It'll still fry like a normal egg, but the bottom will get to the level where it starts drying out. And you do this on a stainless steel pan. Like you don't need to use nonstick or anything like that. It will dry out and then it'll just naturally destick. And then you'll be at this point where you can essentially replace like nonstick pans, like all these other things start to not be as required because you've done the thing that like pro chefs are good at, which is control temperature intuitively, but the stove does it now.
Yeah, this is one of the things I got to do when I came and played with it at your office was fry an egg in a stainless steel pan with no sticking, which is honestly, like, I hate nonstick, and I've been trying to master this at my house with my gas stove, and it is nearly impossible. So that was really fun for me.
And this is why people like cast iron, right? Because cast iron is big and heavy, and once you get it to temperature, it holds consistently. It's also why like the first pancake never comes out well, because it's really hard to control temperature. But again, the first pancake, we've solved that problem. We've also, a watch pot boils. Like a number of these like maxims are now being rebuked fully. That's kind of the like overview of like what the experience is and why you would want to put this in your house, which then kind of leads to the next point, which is why haven't enough people deployed batteries in their houses?
Yeah, why? Tell me more.
Yeah, so I will give you a little bit of a story, which is I almost was allergic to this when people kept asking me like for this feature. They're like, hey, does the stove work in a power outage? And the answer is yes, it does. But it's kind of like the big reason people buy batteries today is twofold. One is they got stuck on NEM 3 and they need to get a battery. And so NEM 3 is the like California rate that It doesn't let you really sell excess solar onto the grid as well as NEM 2 or NEM 1 or whatever.
If you have solar panels on NEM 3, you basically have to have a battery.
You basically have to have a battery. So basically, people are buying batteries attached with solar just to make the solar economics work. That's like the first one reason. The other reason is like you want to make sure that your house works in a power outage. And that's like the actual product reason why you would want it. Like it's probably that one, and then it's like my energy bill is lower because I've got solar. There is yet to be a reason to sell consumers on any other use case for a battery that's not like, hey, you can use this portable battery to go to the beach or like DJ in the park. So you can think of like the portable use case, like why your laptop needs a battery, why your phone needs a battery. But like, why does your house need a battery outside of kind of this like doomsday scenario? Or like, and then you also think like, where do we actually need these batteries? We need them in cities where we need to upgrade all the electrical infrastructure, and having more batteries there would be very good. But like, how many outages do you get in San Francisco? It's not enough, and they're never when I need to cook. So it's weirdly this power outage thing is like a giant distraction because it is the number one reason for people to get a battery. And that also means that there's only a specific set of consumers that do, which then means that all this virtual power plant adoption and all this other stuff that people are talking about has not broken through well enough because of all of these kind of stack factors. And likewise, the like thermostat situation, like the negative watts or negawatt situation, or like people turning off Bitcoin miners or whatever, like all of these things, like the thermostat one is a good example, is like it makes your house colder or way too hot if you're actually responding to an event through the Nest system. And so that is something where the consumer has to like pay some sort of price for participating. But batteries participating, like that's invisible. Like you're like, there's no consumer consequence here. And for stuff like us, you only need the battery at like 10% to get decent power output from the system. Like it just needs to be not dead effectively. What we've realized is there's a bigger, better, newer way to install a lot of batteries on the grid. And that is we make the most awesome appliances with a number of reasons, both connected to the battery, like you can boil water really, really fast, or not, like this temperature sensor thing, which kind of came complementary to that and allows us to use that high power. You get these awesome appliances, you're convinced to buy them because that is the best appliance you can possibly get. And then we start incrementally deploying batteries, not in a like doomsday prepper mindset, or not in a like I'm on NEM 3 mindset. It's in a like, I want these new capabilities I couldn't otherwise have. And that looks a lot more close to why people got electric vehicles in the first place. They're like, I want to get the futuristic spaceship car or the Cybertruck or what have you, or I want the autopilot feature. Like there's a number of reasons why people get EVs, and they're oftentimes around performance and like quality of the vehicle and the fact that it's got OTA updates and a lot of all this other stuff. Basically, that's like, we're now in that zone, which then means that the flywheel will actually start for getting batteries deployed in homes.
Right. Yeah, I'm going to buy an impulse stove because I want an impulse stove. I'm going to get an impulse battery in my house because I want an impulse stove, not because I'm not buying a battery.
Yes, exactly. And this is also why we have to make sure that category-wise, like even if you've already got an induction stove in your house, we can win that sale. That's the argument. That's the argument, because I think the end game here is like there's a number of competitive like angles to why someone wouldn't get our product. Number of competitive angles to why someone would switch off of gas stoves or something like that. There's a bunch of different ways to solve the problem. You can upgrade your panel. Most people do this stuff when they do a major remodel anyways. Like you're potentially intervening in a situation where someone's already got their walls ripped up and the electrical company is already involved because they want to get an EV charger in their garage, their 2-car garage. And so basically the intercept point is we need to basically win on the product and make sure that the product is like able to stand alone, even if like you've got a 400 amp panel and 240 in your kitchen. We have customers that we've sold pre-orders to that are exactly that profile because of just like the capabilities, or like I can sous vide a steak like in my like just in a pot without a plastic bag. Like they're excited about all that stuff and not necessarily worried about how hard it's going to be to electrify their house. Or they're in Florida or something and it's already electrified.
Yeah, no, I love that. And I think, like you said, Tesla's an awesome example of this working. And I've seen, like we talked to Quilt, taking a similar approach to getting heat pump adoption. As a mechanical product designer myself, who's always like really geeked out on product design, it's really heartwarming to see that like actually good product design can actually have an influence on, climate change and sustainability.
Yeah, and their argument is like the consumer experience is you get a Nest per room, which is actually kind of a crazy, awesome experience. How the air is handled and how it heats it, it's like in some sense, it's the temperature of the room is good, and you get per room control, and that's the like product in a sense, right? Versus this, and then the bona fides for like why them versus other people. It's like, okay, we're more efficient or what have you. Like they've got certain very key KPIs that show they can compete on those axes as well. But it's like effectively the playbook to pitch Quill is very similar to ours, where it's like you will want this thing because you want this thing, and then the benefits on the climate side kind of end up being obvious in retrospect.
So for anyone listening who's thinking this sounds awesome, what can they do? What sounds like you're selling pre-orders?
Yeah, we're going to be starting to ship.
What's the status?
Yeah, we're starting to ship end of this year, but you can sign up for a pre-order at impulselabs.com. We're very excited about getting this thing out and about. Like I think you mentioned earlier, you ran into a Michelin star chef in our office. We're very serious about making sure that serious people treat this seriously and in an exciting way, because I think that's going to be really key to the permission structure around a new brand in the appliance space is, I would say, arduous, because there is the challenge of like, you may have had a relationship with Wolf or Viking from your childhood, and they make induction products that are great. So it's like, though they have the same electronics as what I mentioned, everyone else has, but they make induction products that are great. And so it's like you end up in this spot where we have to make sure that we build a brand with serious levels of trust from kind of the community beyond just maybe the earliest of early adopters, effectively. And I mean, I think part of this is like reverse engineering what has been successful in the past, make sure that we have a very clear performance argument that like lets us stand alone, and then making sure that we work with top flight partners on the manufacturing and design side. So like these are companies and brands that have built stuff that you use every day. Like this is not a new supply chain. This is like, if you've held many consumer electronics devices, you will be familiar. And then the last piece is like making sure that, I'm not necessarily the cooking influencer, even though, if you check my Twitter out, you'll see a lot of fun stuff that I do in my free time. But like the goal here is that this is a product that is not the super, like, this is not the Twitter stove or something like that. We're going to make sure that this is something where people come and find us, are impressed, and then tell their friends in a compelling, authentic way. And that's like, again, I'm not a brand engineer or anything like that, but that's the thinking, at least.
Yeah, the experience is so much better that it'll kind of start to sell itself through referral, word of mouth, and referrals. How much are you thinking beyond this product and stoves, and how unique is the stove as an opportunity to do this kind of sneaky energy storage deployment?
So we can always do a pizza oven, obviously.
Yeah, there you go.
As we mentioned earlier, but yeah, I think that the way to pick on this, just to be kind of like general, is there are a number of appliances in the house that have gas. And the reason they have gas, except for the stove, which is like, I would argue is a user experience thing, is high peak power draw effectively. And so if you go look at what other appliances, let's put HVAC on the shelf or on the wall as in the Quilt case. But you can look at ovens. Preheat is a good example. Like, it needs to use most of its power for preheat and broil. Water heaters. When do people take a shower? You think of tankless. You also think of like, there's a number of things that are interesting in that space. There's already companies treating the water heater tank as a battery itself, right? Like,
right, storing energy in water.
Yeah, storing energy in the water, or superheating the water and having a mixing valve so you can store even more energy. There's already a precedent in that space for that. Laundry is another good example. I think this gets kind of into the crazy zone of like, I mentioned this online, but like, I think there's a number of features for laundry that would look awfully similar to like kind of how we have the temperature control on the stove. And this would be like taking advantage of the AI and robotics advances in computer vision that are going to likely land in 2 or 3 years. Like it folds it at the end would be the user experience, right? But then all of those things have a high peak power, low average power profile. And all of them are kind of scoped. If you get them on 240, a 3 kilowatt hour battery is awfully familiar, that can do the power output we've got, awfully well scoped. And so that then means that there's actually a very straightforward play where we can parlay all of the stuff that we've done so far and through regulatory and compliance approval, et cetera, to future lines of products that then give the whole ecosystem economies of scale.
Yeah, no, it's exciting. And like we said earlier, if you have 3 kilowatt hours batteries in your house, you're roughly at Powerwall capacity already installed.
Yeah, and if everyone does this, because like I actually think that what's going to end up happening is everything is going to have a battery in the future. I mean, we're already getting close, right? Like most people don't have a desktop; they have a laptop. It has a battery. Most people, everyone's phone has a battery. Like a lot of yard equipment is switching to having batteries. Like everything is starting to have a battery. Maybe like it's going to be limit. Like the things are not going to have battery. And even light bulbs have batteries now too, because you can get light bulbs that individually back themselves up. And so my suspicion and what's going to happen is everything will get a battery. And if every major appliance that is like big and kind of in scope for what we're doing has a battery, you would deploy like 1.4 terawatt hours of battery storage onto the grid. I don't know the exact implication of like what that would, and also by the way, it would be at the very edge of the grid. It would be like right where at the end of the distribution network. So this means that every house can essentially not be a peak load at all. Like every house, like you wouldn't need a peaker power plant. You've just like scattered them all to the edge with this battery system. And now you could make the grid dramatically more majorities like renewable without having any sort of issues on intermittency.
Yeah, super cool. I'm just watching the time and I have 3 questions that I close out everybody with. These last 3 questions I ask everybody. The first is, how optimistic or pessimistic are you about the future of our planet and why?
I am very optimistic.
Okay, nice.
And I would say the reason why is the following. There's a lot of noise online on all this other stuff. I've been continuously impressed by the fact that we can actually solve problems in a like technology forward. Like technology has been able to actually go and address some of these structural issues. I also don't view like the warming that we're likely going to have as total doomsday. It's going to be bad, but it's not going to be doomsday. But then additionally, like everything is about to go electric. Like, and it seems like that's just like inexorable passage of time will electrify everything. Like given, like we've already reached escape velocity and that's just going to happen. And certain band-aids will be ripped around solar radiation management, around other climate mitigations, around like maybe even e-fuels for aviation will help do some of this carbon removal. And then we're obviously in the middle of ripping a big band-aid, which is the anti-nuclear movement is going away. And so I think I'm very optimistic because we are actually starting to kind of, the arrow of progress is starting to get into the point of like, we've probably bounded some of the worst case scenarios and we're likely going to, I don't know if we're going to overcorrect, but we're definitely going to correct.
I love that. Who is one other person or company doing something to address climate change that's inspiring you?
I mean, I think there's the interesting, have you talked to Casey at Terraform?
No.
So yeah, but basically the idea is like, I think synthetic fuels are a big story, mostly, and I would argue mostly for kind of solving this long tail problem of like hard to electrify industries and all this other stuff. But what's very interesting about them is like you store them in a tank at the end. And so you can just run, if you can make and same with desalination as well, but like things where you're kind of processing liquids or gases, if you store them at the end and you can make the underlying upfront, if you can make the actual system cheap enough, like the Satwicz reactor or whatever, if you make that cheap enough, suddenly you just run it intermittently and you're fine. And so there's
energy is cheap.
Yeah, doing energy is cheap. And I think there's kind of this interesting game where like we solve these problems, we then get the last long tail of like aviation, space travel, like all of this stuff gets addressed. And it's kind of in the like, it's beyond eat your vitamins. It's going to be exciting in terms of what we're going to be able to do because we'll have abundance on a bunch of different factors. And hilariously, I'm saying this in like, this company makes synthetic natural gas. Still create nitrogen dioxide or whatever if you burn it in presence of nitrogen. But it's like I do think that some of this stuff is we're missing the forest for the trees on like what we could do with a lot of these enabling technologies. Where it's like this will deliver us a Star Trek type universe versus a like we're all going to be living in a degrowther universe basically.
What advice do you have for someone not working in climate tech today who wants to do something to help?
I mean, I would basically say that like, I'll use China as an example. I'd go to China just an amount, but like the big point is if you look from the top down, what the orders are from the central government. And by the way, like China's not, I think a lot of the China takes online are high noise. So I want to say that like, I'm hopefully going to be less noisy than some of the high noise takes. They have essentially determined that to dominate the future of industry, like basically, it's kind of like getting into steel and oil in the 1880s. They've determined that it's basically solar, batteries, power electronics, all of those kind of key building blocks that like let you make an electric vehicle. And also, again, chips, software, et cetera. That is all like the enabling tech that they view as like the next industrial revolution. And they're putting their money where their mouth is, but like you can too. And so my general sense is like we're in the process of rebuilding our entire industrial universe around all of these enabling technologies. And so in some sense, anything that kind of touches core industry will be a climate change job of the future, or you could reinterpret it as that. Because we've got now tech that is fundamentally better. And this is like why we're able to deliver a stove that's awesome. But it's like we now have a different toolkit. A toolkit of that's going to let us have like much better power output, much better control across like a ton of different things beyond just like home appliances or whatever. It's not too late. Like we were kind of at the first wave of this in 2010, go work at Tesla or whatever. But now it's kind of where, okay, we've now proven that this works and are going to apply it literally everywhere.
Yeah, the kind of diversity of opportunities out there is kind of insane.
Yeah.
Of opportunities to reinvent things like what you're doing based on this new enabling technology that's available.
Yes.
Awesome. Sam, that was really, really fun. Thanks a lot for your time.
Thanks for hosting.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.